these are the answers to the homework that's due today. I'll read them straight across. The first one is 3 square root 5, 4, 120, 10 square root 2. In the second row, the answers are square root 21, 6 square root 6, 30 square root 2, 3 square root 2. In the next row, we've got 3 square root 3, 2 square root 6, 84 square root 5, and square root 30 over 3. 30 can't be broken down and simplified any. There aren't any pairs when you split apart the 30, so it's going to stay square root 30 over 3. In the next row, we've got square root 3 over 3, 2 square root 6 over 3, square root 30 over 10, square root 15 over 5, square root 14 over 8. In the bottom row, 2 square root 3, 2 square root 14 over 7, square root 30 over 12, and 1 whole for the last one. Let's pick a few problems from that page to go over how to do. Here are a couple questions from the front side of the worksheet that we're going to go over how to do. So they're kind of all mixed around on the worksheet. You'll have to find them. But that first one, square root of 5/8 times square root of 2/6, there's lots and lots and lots of ways that you can do it. But the way that we learned yesterday, if you're multiplying square roots, you're going to multiply the inside stuff. And with fractions, that means we're just going to multiply straight across. So this is going to equal the square root of 10 over 48 to start with. So I just multiplied the inside numbers. Now I have a square root in the bottom, which is bad, but before I get rid of it, I'm going to reduce that fraction, because 10 over 48 can be reduced. Both of those can be divided by 2. So that's the same as the square root of 5 over 24. You wouldn't have to do that step, but it saves you some work later on. Now yesterday we learned that if you have the square root of a fraction, that's like the square root of the top over the square root of the bottom. And to get rid of a square root on the bottom, we're going to multiply by that square root. So I'm going to multiply the bottom by square root 24 and multiply the top by square root 24. On the top, when I multiply 5 times 24, I get, I think, 120. And on the bottom, it'd be a really big number in the square root, but the square roots kind of cancel out. Square root 24, square root 24, it's just 24. So I'm going to break apart that square root of 120 and see what I get. 120, there's lots of ways to break it up. I'm going to do 12 times 10, which is 2 times 6. And the 6 breaks up into a 2 times 3. 10 is like 2 times 5. And when I go to look for pairs, I'm only seeing a pair of 2's. This 3, 2, and 5 are all left without pairs. So that 2 is going to go outside the square root. And inside I'm left with 3 times 2 times 5, or 30. The bottom is still 24, so this one's basically done. The last thing I'm going to do is reduce the 2 over 24 and make it 1/12. The square root of 30 is going to stay there. Right. This next one, so that was all for this first problem. This next one, I'm going to multiply the outside numbers together and then multiply the inside numbers together. Then I just need to break up the square root and see if it can be simplified. There are lots of ways to break it up, but at the end, you should get 3 times 3 times 2 times 2 times 5. So you've got a pair of 3's, one of those 3's will go outside. You've got a pair of 2's, one of those 2's will go outside. And the 5 doesn't have a pair, so it stays inside the square root. That's just for the square root of 180. there was still a 14 being multiplied outside all of that. So the final answer is whatever 14 times 3 times 2 is. So 84 square root 5. Again, to get rid of a square root in the denominator, you need to multiply by that square root. So I'm going to multiply the top and the bottom by the square root of 5. Both of these numbers are in a square root, so I multiply them together and get the square root of 15. Over, on the bottom, it would be the square root of 25, but the square root of 25 is just 5. Now you got to check and see if the top can be broken up. When I break up the 15, there aren't any pairs. So it doesn't simplify. It's just going to stay square root of 15 over 5. On this one, you can't make it 3 over 1 and reduce the fraction because the top is inside a square root and the bottom's not in a square root. So they're like not like terms. You can't put them together. The last one, there's a couple ways to do it. The way that you probably thought of is to multiply the top and the bottom by the square root of 6, just like we did on the last one. But I can show you a shortcut first. Both ways are going to work. This way is just a little bit shorter. The shortcut kind of relates to this last one. Both of these are in square roots. And so since they both are in square roots, we can just divide them out and do 72 divided by 6. So 72 divided by 6 is 12. So this whole thing really just equals the square root of 12. And then I have to break down the 12 and get an answer. So we're going to end up with 2 square root of 3. Now that's the shortcut, by dividing the numbers first before you start rationalizing the denominator. It's going to work this other way too. We're just going to have bigger numbers. When I multiply by square root of 6 on the top, I end up with, I think, 432. And on the bottom, square root of 6 times square root of 6 is the square root of 36. And the square root of 36 is just 6. Now we need to break up this square root of 432. Well, I happen to know that 432 is 72 times 6. And then I can break it up from there. When I do, I get a pair of 3s, a pair of 2s, and another pair of 2s. So outside the square root, I have a 3 times a 2 times another 2. Inside the square root, I have a 3. And all of that is being divided by 6. 3 times 2 is 12, square root 3 over 6. And the 12 divided by 6, since they're both outside numbers, I can divide them, equals 2 square root 3, the same thing that we got when we did it the shorter way. So if you recognize from the beginning that you can reduce the fraction and actually divide, like 72 divided by 6, it makes it a lot easier to simplify. Answers on the back side of the worksheet. The first one is 12 plus 2 square root 3 over 33. Second one is 24 plus 8 square root 2 over 7. The third one is 54 plus 9 square root 2 over 17. In the next row, you get 3 minus the square root of 5 over 4. And square root 3 plus 5 over 2. Below that, finding the missing side of the triangle, the missing side ends up being the square root of 125, but you have to break apart the square root of 125, and your reduced, simplified answer is 5 square root 5. Distance formula, when you make your little triangle, one side is 3, the other side is 4. You're looking for the hypotenuse, which is the distance. On that one, it is 5. On this one, your triangle has 5 for both of the legs. So when you do the Pythagorean theorem, you get that the distance is the square root of 50. But when you break that apart, it simplifies to 5 square root 2. Both of these have a negative in a square root, so both of them are imaginary. They're going to have an I with it. This one's actually positive, not negative. The answer is just positive 5i. And this one is 8i square root 3. So let's go over some questions from this side of the worksheet. Like this one, 1 over 3 plus the square root of 5. When it's a 3 plus square root of 5, you can't get rid of it by just multiplying by the square root of 5, square root of 5. That doesn't work. What does work is multiplying by the conjugate. And the conjugate is when you use the same numbers, a 3 and a square root of 5, but instead of a plus in between them, it's going to be a minus. So 3 minus square root of 5. 3 minus square root of 5. The top only has a 1 thing, so that 1 gets multiplied to both parts. So it stays the same. On the bottom, it's a two-parter times a two-parter, a binomial times a binomial. So we need to FOIL it out. 3 times 3, 3 times negative square root of 5, square root of 5 times 3, and then a positive square root of 5 times a negative square root of 5. Positive times a negative is a negative, and you could write it a couple different ways. You could write it as the square root of 25, or you could just know that that's 5. The square roots cancel out. This makes the square roots all disappear from the bottom, because the negative 3 square root of 5 and the positive 3 square root of 5 cancel out. We already said that the square root of 25 is just a number, it's just a 5. So then let's subtract. 9 minus 5. The bottom of this fraction is just 4. The top stays like it is. 3 minus square root of 5 over 4. Let's take a look at another one. 18 over 6 minus the square root of 2. It's another one where the bottom is a two-parter, a binomial, so we're going to multiply by the conjugate. The numbers are going to stay the same, 6 and square root of 2, but instead of a minus, we're going to make it a plus. The reason we multiply by that is because it's what makes the inside and outside terms cancel out. When you multiply by conjugates, the outsides and the insides are always going to cancel out, and you're going to get rid of the square roots in the bottom. On the top of the fraction, you need to multiply the 18 to both parts. So 18 times 6 is 108. And 18 times the square root of 2 is 18 square root of 2. On the bottom, we have to distribute it all out. So we got to multiply firsts, outsides, insides, lasts. So we'll do 6 times 6. 6 times the square root of 2. Negative square root of 2 times 6. And a negative square root of 2 times a positive square root of 2. A negative times a positive is a negative. And then the 2 times 2 is 4. The square root of 4, another way to write that is just 2. Just like on the last one, the middle ones cancel out and all the square roots go away. Plus 6 square root of 2 minus 6 square root of 2 cancels out. So all that's left on the bottom of the fraction is 36 minus 2, or 34. There aren't any square roots left on the bottom after multiplying by the conjugate. The bottom is just a number, 34. The top of the fraction stays the same, 108 plus 18 square root 2. Another problem from the back side of the worksheet is a review one where we're finding the distance. When we find the distance, we always make a little right triangle and do x minus x on one side, 2 minus negative 1 is 3. And then we'll do y minus y on the other side. 3 minus 7 is negative 4. The distance is the hypotenuse. And to find it, I'll do the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. 16 plus 9 equals distance squared. It is a positive 16 because when you do a negative 4 times a negative 4, that is a positive number. So 16 plus 9 is 25. And when I square root both sides, it turns out to be a nice number. The square root of 25 is just 5. Now, had it not been a nice number, like if it was the square root of 24, then I would have broken apart the 24 and simplified the square root. This one is just one that we know in our head. We know the square root of 25 is 5, so the distance between those 2 points is 5. One last one from the bottom of the sheet, simplifying the square root of negative 192. The first thing you should notice is that the negative is inside, so it's going to be imaginary, and it's going to have an I in the answer. So it's going to be something I square root something. Now I got to break apart the 192 to figure out what goes outside and inside. Looking for pairs inside 192. Since it's even, I know I can divide that by 2, and that equals 66. 66, there's lots of ways to break that down. I'm going to do 6 and 11. So when it's all split up, the only thing I have a pair of are these 2's. So with a pair of 2's, I'm going to put a 2 on the outside with my I, since it's imaginary. And inside the square root is 3 times 11, or 33. Well, okay, so this is not right. That's 96. So that's 96. So this answer's not right. 192, sorry about that, is 96 times 2. 96 is 2 times 48. And 48 is 6 times 8. 2 times 3. So there's many more pairs. Okay, so it's something I square root of something. The ones that have pairs go outside. Pair of 2's, pair of 2's, pair of 2's. So outside I'm going to have 2 times 2 times 2. 1 from each pair. And on the inside is a 3. So 2 times 2 times 2 on the outside is 8 by square root 3.